Dear students, welcome to this course on satellite communication. This is a 3 credit course and CI is going to be marked for 50 whereas SE is going to be marked for 100 marks. There are little bit prerequisite for this course for the better understanding of this that is knowledge of communication system and signals. So what we are going to do as a part of this course is knowing the fundamental of satellite communication, architectural concept of satellite system, launching of satellite, various challenges while launching the satellite, link budget design, modulation and multiplexing that will be particular in context of satellite communication, its application. At the end of this course, we will be able to understand the basics of satellite orbits, the satellite segment and Earth segment, analyze the various method of satellite access, understand the application of satellites, understand the basic satellite network. These are topics which will be going to be covered in this syllabus. In Unit 1, we will cover satellite orbit, which will include Kepler's law, Newton's law, orbital parameter, orbital perturbation, station keeping, geostationary and non-geostationary orbit, look angle determination, limits of visibility, eclipse satellite point, sun transit outage, launching procedure, etc. In Unit 2, we will learn about a space segment, various spacecraft technology, its structure, primary power, altitude and orbital control, thermal control and propulsion, communication payload and supporting subsystem, telemetry, tracking and command transponders, and the antenna systems. Unit 3 will include satellite link design that will cover basic link analysis, interference analysis, rain-induced attenuation and interference, ionospheric characteristic, link design, and with and without frequency reuse. Unit 5 will consist of different kind of modulation and multiplexing techniques, which will be in context of satellite communication, different coding schemes, and Unit 5 will consist of application of various satellites. There will be two reference books. One is Satellite Communication written by Dennis Roddy, and another book is Satellite Communication written by Boston and colleagues. The introductory part of this course, we will learn about um, the satellite communication. Why do we need this satellite communication? Because already we are having terrestrial type of communication. So what is the necessity of using this satellite communication? Then after we will learn earlier stage of the satellite communication, then different satellites, or we can say evolution of satellite, different frequency range and different region for the satellite communication. At the last, we will study about the satellite communication system, and that's all for the introductory part. What is the necessity of a space communication? As we can see here, this is the Earth. This is Earth radius. This is these two are antenna towers. So let's say we are having two antenna towers having radius 1 kilometer, and I want to transmit for the all India radio. So we have to cover Indian land, that is 4 mega kilometer square. So now the interesting question is, how many cellular towers are required to cover Indian land mass? Okay, because we want to cover the whole Indian landmass. So how many towers will be required? So if we will do the simple calculation, then first we will calculate the coverage of one mobile tower, that will be coming around pi into 1 square, that will be 3.14 kilometer square, and the number of towers required to cover India will be the total Indian land mass divided by 3.14 kilometer, that will be 1.27 million. Fantastic, this is a very huge number, and it's next to impossible to implement this many number of towers on the surface of Earth. So we need to think for the other solution. So what could be the other solution? Other solution will be to increase the height of the tower. So a typical tower height is lesser than 100 meter, and it will cover a small part of a city. If we want to cover a very large geographical area, we must have very high, very very long tower, very long tower, or tower height should be we can say 3600 kilometers. That is very big task to implement it. We can't implement this high tower for a simple application. So what will be the next solution? Of solution will be implementing one floating object, that will be our satellite. We can term this as a repeater also. Instead of building such impossible tower, it is easier to orbit the repeater around Earth. A communication satellite is a orbiting microwave repeater that permits two or more users to deliver or exchange information in various forms. Early idea behind the satellite communication. It was started with Arthur C. Clarke, who has written a seminal paper in 1945. He proved that three satellite can help in with the help of three satellite we can cover the whole geographical area of the Earth. So use of three satellite in synchronous orbit to enable intercontinental communication will be possible. So here is the picture. This is the Earth. These are the three satellites. So with the help of these three satellites, we can cover the whole geographical area of the Earth. We can see here, this is the picture which is taken from the INSAT. INSAT stands for India National Satellite. So we can see this INSAT can cover the whole geographical area of the Earth. So if any person want to communicate with or any station want to communicate with other station, that station, the both stations should see the INSAT communication system. That is the primary requirement for the satellite communication. Uh, Once again, if any station wants to communicate with other station, that particular these two particular stations should see the satellite for the better communication. Now, if we don't want to communicate over the all area, if we want to cover the India itself, then we need some smaller satellite. Okay, so that will be known as microwave visibility area. Now we will see the advantages of satellite communication. The very first one is broadcast to very large area. To broadcast our message to a very large area, it is very cost effective, and it can reach through the unreachable area also. The second one is it is reliable solution to last mile problem. No need to get government permission to dig the roads. Because there is no installation of cable and wires for the communication. This is basically wireless communication. And the third point is third advantage is quick setup time with bandwidth on demand. And the fourth one is provide fairness of service as demanded. Diverse user network. It is having diverse user network. See the early idea behind satellite communication. The very first was to use a moon like a satellite, but at night time it is not possible to communicate. So that idea was dropped. Then second idea was to use copper needle, which will be floating in the space, and that will help in the communication. But that is also not a good solution. Then the third solution which came into the picture, it was to use balloon which was coated with the copper, and that was also a passive form of the satellite. So that was neglected, and three different ideas for the satellite communication. One is to implement moon as satellite, second one is copper needle, third one is balloon. So this satellite will come under the passive satellite. So what will be the disadvantages associated with this passive satellite? We can see here. The very first one is Earth station require high power to transmit signal strong enough to produce an adequate return echo. The second one is large Earth station with tracking facilities were expensive. The third one is communication via the moon is limited by simultaneous visibility of the moon by both transmit and receive station, along with the larger distance required to be covered compared to that of closer to Earth satellite. A global system would have required a large number of passive satellite accessed randomly by different users. That is another disadvantage. And then last one is control of satellite not possible from the ground in the case of passive satellites. So another solution for this problem is the active satellite. Satellite will have its transponder units, that is repeater. It will have some amplifier, LNA, those kind of stuffs. So what will be the active satellites advantages? The very first one was require lower power from the earth station, less expensive than passive system, not open to random use. It can be customized and directly controlled by the operators from ground, and that operator can give the permission to use this satellite. And the disadvantages are listed here. These are needs high reliable design to avoid disrupt of service due to failure of electronic component on board the satellite. If any component will fail on board, then what will happen? That communication will get disrupted. So we need to be very careful while designing the active satellite system. Um, so later I will focus on the reliability of the satellites. Then second one is requirement of onboard power supply. There will be huge solar panel required for onboard supply. Then third one is requirement of larger and powerful rocket launch heavier satellite in orbit. So this is like we need very powerful rockets to launch these satellites in the particular orbits. These are the advantages and disadvantages associated with the active satellite. Now we will see different commercial satellite. The very first one is Intelsat 1. This was launched in 1965, having mass of 39 kg. Life was 18 months. Broadcast 1 TV channel. It requires 7 dB watt RF power, that will be nearly equal to 5 watt radio frequency power. And another Indian Intelsat Earth station set up at RV near Pune in 1971. Antenna radius was at 28 meter. Power which will be required to operate this Earth station was 3 kilowatt. LNA should have 50 degree Kelvin. That is very critical to maintain this 50-degree Kelvin in order to reduce the noise. And it was designed by ISRO. And one is Intelsat second version. Uh, it requires C-band. It is having C-band transponder much more. It is having 70 number of C-band transponder, and it's having 36 number of Ku band transponder. This transponder is nothing but a transmitter and receiver section, combiningly known as transponder. This band we will study it later. C band, Ku band, K band. These are the bands. Frequency band that will have certain frequency range. Here, three statable spot beams are required. The weight of this satellite is 5575 kg, and it was launched in 16 6 2004. Another satellite for mobile communication. It was launched in 2005, having weight of 6 ton, and it requires power of 12 kilowatt, very high power. It is having solar panel, which is having like a span area 48 meter radius, and this is having a spot beam, EIRP 67 dBW. Its coverage is global C-band and L-band. For the smaller delay, we need a satellite which is near to the Earth, near to the Earth's surface, and it means its orbit is should be near to the Earth, and it is known as lower Earth orbit. So Iridium is a LEO mobile system. You can see here these are the satellite which is near to the Earth surface. It can help to receive signal for the DTH and uh, voice communication. It is having 66 satellites. Orbit is 780 kilometer. It is having 48 spot beams per satellite. Now we will see the evaluation phase of broadcast since 1975 to 1976 in India. In India has borrowed ATS-6 from NASA. It is having RF power maximum 51 dB watt. All India coverage with 30 feet parabolic reflector. You can see here this is the parabolic reflector. Simple receiver, 12 feet parabolic dish, and it was costed around 10,000. In evaluation phase 77 to 78, India is having another satellite symphony, which requires the RF power 34.7 dBW, and the year was 77 to 79, with PNT collaboration, transportable Earth station. This satellite is having transportable Earth station. So it was the year 1981 when India has first made its own satellite, that is Apple. This is first Indian satellite communication system. It requires maximum RF power 31.5 dBW, all India beam. All India beam. It is having all India beam. Its application includes random access packet switching, TDMA, ISSMA, ISRONet, a continuous step experiment. This figure shows Indian operational communication satellites variation. You can see 48 E till 93.5 E till July 2008. India has 211 transponders. Here INSAT stands for Indian National Satellite. Now coming to the use of satellite communication, the very first one is direct to home broadcasting for television and radio, which we have seen. Satellite news gathering, very small aperture terminal for commercial data transfer. ISP and mobile network backbone. This is backbone of ISP and mobile network communication. Television and radio networking, disaster communication, where all communication means will fail. This will help in communication, building the communication. Mobile communication, remote area telecom, and many more. These are the normal frequency band. Here we can see which is in orange color. It is a microwave frequency range, and this satellite communication will use this microwave frequency range from 10 raised to power 6 hertz to this 10 raised to power 12 hertz. It means till terahertz. The frequency spectrum, we will see the main components of satellite communications. The very first one is Earth station, then one satellite will be there, their satellite control center will be there. This is the space segment, earth segment will be there. So if two stations wants to communicate with each other, both stations should see that particular satellite system. At last we will see how what we have learned from this introductory session. The very first we have seen SATCOM is a form of wireless communication which is covering large geographical area. We have seen the application advantages and disadvantages of different satellites. Uh, these communication satellites are nothing but microwave repeaters. We have also seen the early stages and early history of satellite communication in India and outside the India internationally. So we have learned these things. So that's all for the introductory section.